Welcome to Lab 2 GIS Overlay Analysis. Today we're going to be going through and doing several different types of overlays and answering several questions that then you will go on to bblearn and provide answers for in your lab questions. To start out with, we're going to open a new ArcMap project which I have here, and we're going to make sure that our data from Lab 2 is downloaded. I've downloaded that, so you'll need to get that from bblearn. Unzip it and save it into your class folder. So mine is 407 and lesson 2, and this will be lab 2 data, and it's in a folder called Cellway. To begin, we have a list of data layers to add. So I'm going to navigate to my class folder and add the layers indicated, starting with SBWPVT right here, and you can use your control button to select multiple ones. So we've got an elevation file, fire starts 1986 to 1992, HUC5, which is a hydrologic unit layer, fires in 2000 right here, Idaho state boundary, and a pvt.dbf file right here, and we'll click add. We have unknown spatial reference, that's just fine, we'll define that in a little bit. Okay, so here we are. To start with, we don't need all these layers on, so you have these different options: list by source or list by drawing order. I like to list it by drawing order usually. The reason it goes to list by source is that we have this DBF file in there, and that's where that's available, so you can see that it's available there but not available in the list by drawing order. You can go back and forth when needed. So now that we've added those layers, we first need to turn on our Spatial Analyst toolbar in order for us to start working with these. We're going to add the Spatial Analyst extension for working with raster data. So in the top menu, select Customize and then Extensions. And you're going to make sure that Spatial Analyst is checked. It might not be, so check that box there and press close. And then to display the toolbar, we'll need to go to Customize, Toolbars, and make sure that Spatial Analyst is checked down here. And that'll make the Spatial Analyst toolbar available. And you can slide it up to incorporate it with your toolbar. I'm going to close my layout one. To standardize your output locations, your cell size, your area that you'll be processing in, then you can go to Geoprocessing and Environments. This makes it a lot easier for you to create your output, know that it's being saved to the right location at the right cell size and with the right features that you'd like, as opposed to changing them every time. So we're going to go under Workspace, and we're going to pick our default folder that these the things that we'll be creating get saved to. So I'm going to pick a location, and I'm going to put it in the lab or the lesson 2 folder. And then Scratch Workspace, I'm going to make the same. Just copy and paste that in. And under raster analysis, we're going to make sure that we have the proper cell size specified. And the easiest way to do that is to select a layer that you have that you'll be working with, and then it'll auto-populate with the proper cell size. The mask here is what you would select if you had a very large grid that you'll be working with, and then you are only interested in producing output for a certain area, this is a great way to select a fire perimeter if you're doing analysis on vegetation type or on post-burn severity. For now, we'll just have the SBW PVT as our mask, and later you can go back and change that if we're doing different kinds of analysis, but this is a really great tool to save time in clipping the layers that you produce. So I'm going to explore my data a little bit. I'm going to check off Idaho. We included the Idaho one there just so you could have some reference for where we were. And I'm going to zoom in. One feature that I'd like to point out now that we'll also discuss in the base layers discussion is the opportunity to add base maps. You could press the down arrow here next to plus and add a base map. So if you wanted to see a little bit more about where the imagery was from, you could select imagery or any of these other options. You can play around with those. They are quite large. They might take a little bit of time to load, but it will give you an extra view of what you're looking at. So let's zoom out a little bit. So you can see roughly the type of cover that we're working in and where we are, what kind of geographic features are around us, which is useful. So at this point, it's going to be important for you to save your ArcMap project. One thing that you'll notice when you start working with Spatial Analyst or any of the other toolbars, you increase your likelihood of Arc shutting down unexpectedly, and you'll lose the work that you had done, or it'll be hard to find the place where you were. So I'm going to save as, and I will save in my lesson 2 folder and call this lab 2 overlay. The first task that we're going to do is we're going to join the potential vegetation type to the potential vegetation type grid. The reason for this is, let's first look at our potential vegetation type grid and see what it looks like. So celery bitterroot potential vegetation type. Let's open this attribute table, and pretty uninformative. So we know that we have some values, we know that we have a number of cells that contain those values, but we don't know what those values mean. So what can we do to improve that? Well, let's look at our potential vegetation type lookup table, which is here. Open that, and you can see of a potential vegetation type code and associated with a name. So it would be much preferred for our celery bitterroot potential vegetation type to have that name associated with it as well. So the first thing we'll do is we will right click on the celery bitterroot PVT data, and we're going to select join and relates and select join. So then we're going to enter values. Here we're going to put value. So it's saying look to this column in the SBW PVT file, and in the PVT file we're going to be joining that with the PVT code. So it's saying that this is the value, that this is the name of the column that's going to be the same in both of those files, and this is the one that needs to be added to the SBW PVT file. And then we'll click OK. And now we will open our attribute table and see what's changed. So you can see that we have a lot of additional columns now with some different names, but what we're looking for is, do we have our values and do we have the names of the PVTs associated with them? And we do. And close that. Now we'd like to display our potential vegetation type area so that we can see what that looks like across the image. So I'm going to remove some of these layers or turn them off for now and just get a good look at what we're currently working with. So I'm going to right click, zoom to layer. So right now we have some color schemes that don't make a lot of sense in terms of what they represent on the ground. And so right clicking, going to properties, and selecting in symbology, selecting unique values, And for value field, under the PVT name, we're going to pick some better colors. You may need to add all values if they don't automatically populate. And you could go in and individually select the colors that you like for each of these, but I find that usually there's a decent match in the different color schemes. This one does seem to represent vegetation well, so maybe try a couple out and see if they do a good job. So the main thing is that blue needs to always represent water. If it's anything else, it gets confusing. So this looks decent to me. I'm going to press OK. And now I can see a better representation of what those potential vegetation types are on the ground. So now if you were to close this ARC project, or if it were to close unexpectedly, and then you were to re-add these layers, you would have to go through that same process again. One way to save that step would be to right-click on the layer that you've been working in and save as a layer file. So if I navigate to the folder that I'm working in, and this would be saved as the sbwpvt.layer, and I would save that. Then in the future, if I opened up a blank ARC map, and then I could add that. It's not a part of this exercise, just something useful for the future. In this and other exercises, we will be doing quite a lot of changing to individual layers, so you might want to save those changes. Let's just test that out. Let's see what that layer looks like when we add it. So if we were to add the layer we just created, it would look like this. Add. It's acceptable for now. As you can see, it's in the same settings. And if we opened the attribute table, it would have the same attribute table. Let's add the original file. So as you can see, it's got a lot of different colors, haven't been adjusted, and the attribute table has not been altered. So we have to do that work again. In this next step, we'll be answering some of the questions that are included in your lab questions. So make sure to have your lab notebook out, take notes on what the answers are, and then when you get to the lab questions, you can simply insert those numbers in there. So the thing that we're going to be the first question we'll answer is how many fires started in the Selway Bitterroot Wilderness in the time period of between 1986 and 1992. We want to know what the fire occurrence rates are. The first thing I want to do is clean up my table of contents. I'm going to press the control button and I'm going to press this minus key. It closes everything or minimizes everything. I'm going to go back to my table view, minimize that, and then I'm going to turn everything off and just turn on my fire starts. I'm going to right click on this layer and open the attribute table. And I'm going to locate the total number of fire starts, which in this case, each row is one fire start. And so the number of rows will indicate the number of fire starts in that time period. And as you can see here, this is a total, so 641 fire starts there. Second question is how many of those fires have a final size larger than 1,000 acres? So in this attributes table, we're going to click the table options, which is up here in the upper left corner, and we're going to select by attributes. First, we're going to double click on fire size, final size. This is a column in the table, so it's saying look in the final size column and find any of those fires that are greater than 1,000 acres. And when you are working in any kind of dialog box like this in ARC, it's best to use the options included in the dialog box as much as possible. So don't type in the greater than symbol from your keypad. Try and press it there, and then I will type in 1,000 and then click apply. So now you can see how many fires were selected out of those 641 that are larger than 1,000 acres. For the next several questions, you'll need to be making a summary table to compile the information. The question is, what are the causes of fire starts in the Selway Bitterroot Wilderness between 1986 and 1992? And so we'll keep this attribute table open and right-click on the heading for the fire cause column. Let's locate that. And ARC includes a tool for summarizing column information. And we're going to expand the option down here for final size. So these are the where you select the outputs that you'd like to see. And since our question is about the total number of fire starts for the Selway Bitterroot, we're looking for a sum. So we'll want the sum of those fire starts. We'll click, make sure that it's going to the right place here, that's acceptable. Might change that name to fire cause summary. And then click OK. And I do want to add the table to the map. I'm going to close this dialog box and take a look. Notice it's under one of these folder options here, so fire cause summary. I'm going to right click and open this table. So now I can see that I've got a fire cause, the number of fires that fell under the classification of that cause, and then the sum of the fire size for those causes. With this information, you can answer the question in question 3. Now we can see that there were 2 different types of fire causes, and the number of fires that fell into each of those fire cause classifications, and how many acres those fires resulted in. In order to understand what the cause of those fires were, other than just a number, you can refer to your lab, and there's a list of the numbers associated with those. This list comes from the metadata, which is associated with this file. And metadata is background information that provides additional information when those layers were created, or like in this case, extra information on what those numbers might mean. Let's take a second to look at the metadata file. When opening this up outside of the ARC environment, you can see all the additional base layers, and so it is a little bit harder to find things. Let's go to the fire start file. So we're looking for the .dat file, and in order to open a file like this, we'll need to right click on it and select open with, and I'm going to find additional apps to open it. I'm looking for either Notepad or WordPad, some kind of basic Word document. And in this file we have the creator of the information, when it was created, lots of background information, and then the descriptions for fire starts. So all of this information we'll work with a little bit more in the future, but this is great, a great way to find out where the files that you're working with were created. And as far as passing information off when you're working as a GIS specialist, those metadata files become very important to save what was done to those images. So back to our ArcMap project. The next 2 questions, question 4a and 4b, you can answer using similar techniques. And again, going back to your main attribute table here for fire starts, and using the summarize table and making different selections. So go ahead and do those ones on your own. Next, we're going to be moving on to point to polygon, and this is a spatial join, and it's different from the joins that we had done previously. Instead of adding a field to a table or a column to a table, we'll actually be creating a new output layer, since these are going to be pulling information from two different layers and making an additional feature. So the answers to this question involve an overlay analysis or spatial join between our HUC5 layer, or a fifth order watershed, and the point layer of fire starts. So we're going to go to my drawing order here, and I'm going to turn on my HUC5 layer and my fire starts. And the first thing that I'd like to do is join a portion of these layers. So I'm going to right click on my fire starts and select join, joins and relates, and join. And under the question of what do you want to join in this layer, we're going to select join from another spatial location, which gives us some different features here. So it auto-populates with HUC5 since that's the first one on the list. And we're going to name the output layer and store it in the appropriate folder. Now, notice that as I've been doing this, that these have been saved to the folder that I have intended. That's because when I set up that those initial options for Spatial Analyst, the geoprocessing options, that has saved me the step of having to redefine where I want to save each of these outputs. But I would like to change the name, and I'm going to change the name to Fire Locations HUC. And press OK. So our output's been added, and it's a point layer, and I'm going to open that attribute table, and I'm going to use the summarizing that we had done previously to summarize the number of fires in each watershed. For this attribute table, first sub is the attribute name that contains the name of the watersheds, which will be what we refer to. So this is first sub. So unlike the previous part of this exercise, you won't need to select something like finalize, since we're going to be just looking for the numbers of fires that occurred within each watershed. So since this is the different names of the watershed, I'm going to right click here and click summarize, and just make sure that that's the proper location, which it is, and rename this to something meaningful like number of fires HUC5, and we'll add that to the table, and then we will open that attribute table, and we have a handy dandy summary of the name of the different watersheds and how many first sub, or how many fire starts, there were in each of those watersheds. Now remember again that ARC will periodically crash, so I'm going to take this moment to save my work. In the next step, we're going to derive slope and aspect from your elevation layer. So in ARC 10, raster tools are located in the Spatial Analyst Tools toolbox in the ARC toolbox, which is located up here somewhere. It might be different for your computer. It's a red toolbox. Click on that to open it, and it might open freestanding. You have a couple different options of where you can place these. You can double click on the top and it'll bring it to the side and cover up your table of contents and turn that into a tab. You can also make this small. You can auto hide it, and then to remove that, you can pin that again, and you can close this out here. Now if you accidentally close your table of contents, which has occasionally happened to me, and it's taken me a while to find it again, it's just up here next to the ARC toolbox. So table of contents, and I'm going to open my ARC toolbox, and I'm going to go to under Spatial Analyst Tools, Surface, and Slope. Double click. For my input raster, I'll select elevation, and this is an acceptable location for my output raster. And I'm going to keep this in degrees and the z factor of 1, and I'm going to press OK. Now, while ARC is calculating, sometimes I get a little bar down here that helps me know that it's processing, and sometimes I don't seem to get that. Another way you can check to see how things are progressing is you can go to geoprocessing and go to results. And now you can see that I've got a little timer here. These are some previous slopes that I've calculated, and one of them threw an exception after about 2 minutes, and then I reran it again, and this second one took about 20 minutes to run, but ran eventually. And then this one here looks like it completed just fine. So if you do have some problems, just try running it again and see if you get any kind of different result. So it's completed. You saw a little message pop up in the bottom right corner. Close this out. And now we'll do the same thing for aspect. Input raster is elevation, and then notice it's labeled aspect SPW. We'll keep that at the same. Click OK. And we're processing aspect, and I'll just check my geoprocessing here. Looks like it's working on that. So now we have our slope and aspect layers have been added. I'm going to close my ARC toolbox and look at what's been created. So here's our aspect, and here's our slope. And we'll use these slope and aspect grids later in the lesson. The next step we'll be taking is an overlay analysis with point to grid, and you'll be using what we do here to answer questions 6 and 7. So we're going to be looking into how many fires started in each potential vegetation type, and if the fire starts were random, and the number of fires in each of the PVT that would be proportional to the area occupied by that PVT. So in order to determine if the fire starts are random, you'll need to calculate both how much area is in each PVT and the number of fires in each of those PVTs. So the first thing we need to do is to calculate the area, in this case from a grid. So we're going to right-click on the layer that we are curious about and open its attribute table. Minimize these for now. Turn off slope. So first I'm going to clean up my table of contents a little bit. I have a couple of extra files here that I was using to demonstrate. So now we're going to talk about how to calculate area in a polygon and also a raster grid, a raster layer. So we're going to start with this hydrologic unit layer, and each of these polygons has an area, but currently in the attributes table we do not know what that area is. So we're going to need to add a couple of columns and do some calculations. So to begin, I'm going to go to Table Options and Add Field, and I'm going to label this acres. And these areas here are where we specify the length of these, of the number of values that's going to be in each of these fields. So just as a demonstration to show you how to do this one way, and we'll do another way next, but we'll start with double. This is going to help us determine how many values are going to be to the left and right of the decimal place. So we're going to specify 12 values to the left of the decimal place and 2 values to the right, and select OK. And now I need to calculate my acres. So right now there's nothing in there, of course, so I'm going to go to Calculate Geometry, and this asks me if I want to do this outside of an edit session, and I will say yes. And we're going to be calculating area, and we'll keep it in that coordinate system and choose acres. So make sure you're picking the right one here and click OK. Yes. Now we have our acres. So just notice that because we specify that there are 2 decimal places to the left, we have not too many rounding errors, which is what we're going for. And now we need to add a column for hectares. Add field, hectares, and double, 12, 2, right click and calculate geometry, yes. This time I'll select hectares, click OK, and yes, great. So moving on now to rasters. So here's our SPW PVT that we worked on before. And if you notice here in the attributes table, there are lots of extra values in each of these columns. Now, if you were to go through and try this process that we'll walk through here before we make this a different, more permanent layer, then you would receive an error message. So in order for us to calculate area on a raster layer that's been joined, we need to first make it a new layer. So previously we made this a new layer and we saved its symbology. We saved how it looked. But it still wasn't a permanent, a new shapefile. So we need to make this a new shapefile. It's not going to save the visual aspects that we've changed here, but it will save the background join. And that's going to allow us to do calculations on that. Right now, again, this is just kind of a surface join that we've done, and then these surface visual colors, and we want to make this more of a permanent layer, or a permanent shapefile. So we're going to go to Data, and Export, and specify its location. The output folder is fine. And instead of a TIFF, though, I'm looking for a grid. And I'm going to make this number 2 for me, since I've done this once before, and click Save. And yes, I want to add it to the map. So the colors have changed, reverted back to just random colors. But now, if we open our attributes table, we see that combined between the names and the count is permanent. So if you want to take a second to go and adjust those properties, then at least it'll look nice while you're doing your work. Just because I'm picky, you can make sure that water is blue and your other values are not blue. That'll work for now. Okay, so calculating area. We're going to open the attributes table here, and similarly we will add a field and label this acres, and this time we're going for long integer. And there is a reason for that, but we're just going to stick with long integer for now. Click OK. Now, we need to figure out how to calculate area. We don't have this calculate geometry option. That isn't available for rasters, so we use the field calculator. And yes, we again want to edit outside the edit session. So we have to think about what we know about this raster and then how we can apply a calculation to get area. So we have a count. So we know the number of cells that are in each potential vegetation type. We also know the area of those cells. Each of those cells is 30 by 30 meters. So 30 by 30 meters is equal to 900 meters squared. Think about that for a moment. There are 900 meters squared in 30 by 30 meters. So how many meters squared are in an acre? When we do that calculation, we can figure out, or we can determine that there are 4,047 meters squared in an acre, which means that if we want to know our calculation to get from count to acres, we need to take 900 divided by 4,047, and that gives us 0.2224 acres in each pixel cell. So we take the number of pixel cells, or count, and multiply that by 0.2224 and click OK. So here are our acres. Now we need to calculate our hectares. Add a field. Now label this one hectares. So click OK. And field calculator, yes. So it saves that equation in there, but this time, since I'm doing hectares and not acres, I need to figure out how many square meters are in a hectare. So for a hectare, we have 10,000 meters squared in a hectare, which means that we would take 900 divided by 10,000, and that gives us 0.09 square meters in a hectare, or hectares in a pixel. And press OK. So now we have our area. So next, in order to calculate the questions, we need to open an Excel table. So you can open up a new Excel spreadsheet, or what actually might be best is if you go to your folder for 407, and you can add new Excel spreadsheet, label it. This is a nice technique to use if you don't want your data to be lost. If you open a blank Excel spreadsheet or a blank Word document without anchoring it somewhere first, it's more likely to disappear on you. All right, so you have your lab, and the table has been given to you there. This is just a little bit of a tutorial in Excel. So you'll get to their table, and you can copy this whole thing in, and then paste it. Excel is an incredibly handy tool, and one that you should develop some familiarity with if you have not already. So the question is that we want to export, or we want to fill in some of this information. So we want to know what the area in each PVT is, and the number of fire starts, the percent of fire started in that PVT. So what we need to do is go back to Excel, or go back to ARC, and we need to export this data. We could just enter it by hand, and you're welcome to do that, but again, this is a process of learning, so go ahead and try and follow along with me. So we're going to go to Table Options and Export, and it's going to export as a DBF file. So I'm going to click, actually export, that's just fine. So we'll click OK. You can name it something if you'd like. I'm going just with normal export. Do we want to add it to the map? No, we do not. And we are going to now relate points to grids. So the spatial join procedure that we worked on in step 6, this only works with relating points to polygons. And so in order to relate points to grids or raster data, we need to go to use the Spatial Analyst tool. So let's find that here. So we can go to Spatial Analyst Tools and Extraction, and then extract values to points. So our input feature is going to be the cellway fire starts. So we're going to relate this fire starts to these PVTs, and we're going to use the input raster as PVT. We'll just go with a PVT2 since that's the one that we had, or the whatever it might be named for you, the one that we had made permanent. And we're going to name this, add this to our output file, and name it SBW PVT fire starts. I'm going to add a 1 next to mine. Click OK. And it's probably working on this process right now in geoprocessing. If you want to check on it, you can go to geoprocessing and results and see that it's working on that extraction. So that extraction is done. So now we have a point layer that's been added. So I'm going to close this and I'm going to go to my new layer and open the attributes table. So this attributes table looks really similar to the fire starts attributes table, but with the addition of this column of raster value. So this is giving me the raster value under each of these fire start locations. In order to know the names of these raster values, I'm going to do a join that we went through in step 2. So I'm going to close this, I click here, joins and relates, and join, and select raster value, and again still joining to PVT code, and click OK. So now when I open my attributes table, not only do I have the raster value number, but also these PVT names. So just as we did in step 5, I'm going to be summarizing the values from this column. So I'm going to click on this and select Summarize. And I'm not looking for any specific value in here, so I'm just going to keep this as sum output 3, which is fine for now. And yes, I do want this added. So I'm going to open up this summary. So what this gives me is how many fire starts are in each of these different potential vegetation types. So now we have all the information that we need to populate our table. So let's go to our Excel spreadsheet that we created here, and first we're going to open the DBF file that we saved previously. So I'm going to go to File, Open, and let me move this here a little bit, and go to our export file, our output file. And we are looking for, so initially yours will likely open up as all Excel files. With this, you might see export outputs, but this is not the file that you are looking for. You are actually looking for the DBF file with that type. So we're going to go to All Files and select the DBF file right here and click Open. You may be asked about formatting, whether you want comma or space delimited. You can just move through that process. So we have our PVT names and acres. These are in the same order that this table that you copy from your lab are in. So I'm just going to copy the acres here and go to my Excel spreadsheet for the lab and paste in acres. It fills in all those spots. So minimize this and close this out. And now we need to type in some of these PVT, the number of fire starts in each PVT. And I am not going to add each one of these, so I can encourage you to do that on your own. But I will do a couple so I can demonstrate some Excel strategies. So you can do 14 grand fir is 58, and so on. So we have, we'll have all these different values. Now we need the number, or the percent of fires started in PVT. So to get this, we need to have a total number of acres, because if we're going to do a percent, we need to have what the total is. So I'm going to make a new place here for total, and I'm going to say sum. So in Excel, to tell it you're doing an equation, you just press equals, and then you write in sum and a parentheses, and it's telling me that it wants me to highlight these numbers. I'm going to go ahead and expand this out, and I'm going to highlight all of these acres. This is going to give me all the acres for this whole area. And for number of fire starts, or percent of fire, it's going to be again an equals, and I'm going to say what percent is this PVT compared to the total. So I'm going to say equals this value and divide by the total, this value here, and then multiply that by 100. Better put some parentheses in. It's always best to put parentheses in. So this is 2.7% of the total area. Now, the beauty of Excel is that I can then take this equation and drag it down to all these other values. The problem is that then it moves. You see it's moved down there. So a little trick that you can do is you can add a numbers sign to keep it in the same place, but I should do that before. So I'll do it from up here, do a little numbers sign to tell it to always look at that 13th row. And then I can put my cursor here, get the little black T there, and double click. It's going to bring it down into as many numbers as I have. And notice that it's moved down one value here, but it's stayed on the sum value there. And then we've got the percent area in PVT. Oh, but it looks like I should have done this calculation in this column. So that's stayed in the right place, so we're good there. This is the percent of fires started, so this one is going to be a little off for you since I did not do all the numbers in here, just so that you're encouraged to do it on your own as well. But for demonstration purposes, here we are, sum, and I'll add all these together. And would put in equals this value, I'll do parentheses again, this value divided by sum, and times 100. So that's going to give us the percent of fires started in this PVT. And again, you would take this, you do your money sign, and you would drag this down, and that'll give you all those percents. Then this final calculation is the ratio, so it's going to be A divided by B. So again, equal sign, A divided by B. So the percent of fires started in the PVT. And what this is going to tell us is if these fire starts were random, or if there were some potential vegetation types that had statistically more fire starts compared to their area, or less fire starts compared to their area. So with this information filled out from the table, you should be able to answer the following questions. We're now going to cover polygons on grids. We're going to be using something called zonal statistics, also tabulate area and combine, which are all parts of the raster calculator. Zonal statistics computes statistics such as the minimum, maximum, mean, and range in a certain area. Tabulate area cross-tabulates two grids or polygon layers with a grid. And combine also cross-tabulates two grids, and the outputs can be shown spatially. So these are three different tools, and they all have slightly different uses. So to begin, we're going to go again to Spatial Analyst Tools. And we're going to go to Zonal and select Zonal Statistics as Table. Our input is going to be our HUC5 layer, so this is our polygon layer. And the zonal field will be first sub. And the value raster will be SPW elevation. And for now, we can just leave this with the default name. So now I'll click OK. And it's going to be processing this as a table. So the output table that we'll receive is going to be the min, max, mean, range, etc. for each of these polygons, each of these watershed polygons. Open my table up. And so for each of these different watersheds, I have min, max, range, mean, elevation. So this gives me the whole spectrum of elevations in each of those grids. Now, if you were running this process and your computer threw an exception, just a warning that comes up, just try running it again and it may process no problem. And if that doesn't work, then try saving and then restarting Arc and trying it again. So now you can take the information from this table and add it to the table in your lab and complete that question. So next we're going to be going back to Spatial Analyst. And this time we're going to select Tabulate Area in the Zonal Tools. And again, we're going to be using our HUC5 and also first sub. And this time our input raster is going to be SVW PVT. This is the most current one. And keep this as value. And we can name this if you'd like. I'm going to keep mine just as it is and click OK. And I'm going to take a look at my table. So the numbers in the table represent how many square meters of each PVT there are within each watershed. So for example, there are 0 square meters of the potential vegetation type 2, which is western red cedar, in the first watershed on the list. So our next step that we'll be doing is doing a grid-to-grid comparison. GIS overlay analysis is a really useful tool in planning and stratifying sampling locations for vegetation and fuels. In this example, we are planning a stratified sampling procedure by aspect, north, east, south, and west, and potential vegetation type. So the first thing we need to do is we need to reclassify into 5 classes. So we're going to be manipulating our elevation layer, or our aspect layer here. So we'll go to Spatial Analyst Tools again and reclass. Now this reclassification process is something that's used all the time for lots of different purposes, so it's an important process to become familiar with. So we're going to go to reclassify, and we're going to select our aspect grid and select value there, and I'm going to choose classify. And I'm going to change the number of classes to 6, which you'll see will be north, flat, north, east, south, and west. So over here I have north is going to have 2 parts. North is 0 to 45 and 315 to 360. So we're going to make our breakpoints here. First we're going to have the breakpoint be 0 and 45. Oops. $135. 225, 315, and 360, and click OK. Now we need to change these values. So our first value here is going to be 0, and these are areas that are flat, that have no aspect. Our next one is 1, and then 2 for east, 3 for south, and then 4. And after 4 we actually go back to 1 because north is both 0 to 45 and 315 to 360. So north is both these two categories. And we're going to name this layer aspect rec. And it will be a little bit easier if you do follow this naming scheme. So naming it aspect underscore rec and click OK. So now that we've reclassified this aspect layer, we are going to combine it with the PVT layer to be able to find the stratified sampling locations by aspect and PVT. So we need both of those in order to pick our sampling. So we're going to go to Spatial Analyst Tools again, and Map Algebra, and Raster Calculator. And we're going to enter the following command. So the easiest way to do this might be to go to your lab and just copy and paste this equation in. Now it's important that you have labeled your aspect rec the same as this equation. If yours is a different name, then you'll need to replace this. So you would highlight this whole thing and then you would double click your layer for aspect that's been reclassified. So mine should match this equation just fine. And I'm going to name this PVT aspect. And click OK. Looks like I need to name it aspect 1. So now we can look at our results. I'm going to open the attributes table so we can see that here's the number of pixels, here is the SPW PVT, and the aspect. So we have this combination, but we want to have a better association of what these PVTs are. So again, we're going to do a join like we did in step 2. We're just kind of reusing some of these skills here so that you can hopefully have a little bit more remembrance of how to use them in the future. So we're going to select SPW PVT, go to that PVT table, and PVT code. Click OK. So now that we have a joined table, our next desire is to have area calculated. So we are going to need to make this a permanent shape or permanent feature. So I'm going to export the data and change this to a grid, and I'll just leave that name the same. Click Save. And yes, I want it added. And so in this attributes table now, it's been saved and we have the names of the PVT and of the codes. So now we'll need to calculate area, and we're going to do this in hectares. Long integer. Click OK. And select field calculator. Yes. Count times 0.09. Click OK. And there we have our hectares. And so to summarize for this Douglas fir potential vegetation type for your question, we're just going to go sort ascending and locate our Douglas fir and find the hectares that are associated with that. That is the end of Lab 2.